Good morning, children. Today, at first, I want to recall what we have learned in our previous class. In the previous class, I have started Chapter 10 circle, and especially we learned two new things, that is secant on a circle and tangent of a circle. What is secant? A line which passes through the circle and it intersects 2 points on the circle is called secant. And what is tangent? A tangent is what? It will intersect at a point on the circle. It is also a line. Second, it will intersect at 2 points, and tangent it will intersect at 1 point. So I hope all of you understood, and we got theorems 10.1 and 10.2. Theorem 10.1, what we got? The line joining from the point of contact of a tangent to the center. That means if a line joining from the point of contact to the center, it will become what? Radius. And this line means this radius is always perpendicular to the tangent. I hope understood. Next we learn the length of the tangent drawn from an external point are always equal. If you draw tangent from an external point, then the length of the tangents are always equal. These two theorems we got, 10.1 and 10.2. After that, I have done exercise 10.1 and 10.2. So maximum number of students has already submitted their homeworks, and I have seen they have done it correctly. So today I am going to continue exercise 10.2. Okay, let's start the class. Chapter circle, exercise 10.2, question number 7. Okay, today we will start from question number 7. Two concentric circles are of radii 5 cm and 3 cm. Find the length of the chord of the larger circle which touches the smaller circle. Okay, concentric circle means you already know. The concentric circle means the one center. Okay, means there are two circles and common center. So first of all, you have to draw the figure from this given information. See, two concentric circles, one radius is 5, another is 3. Okay, when you draw circle, please use compass and pencil. Okay, this is two circles. This is common center, 5 cm and 3 cm. And also it is said that the length of the common chord of the larger circle means the common chord of the larger circle which touches the smaller circle. Suppose I am taking, this is the common chord, this is the chord, okay, larger circle, and which intersect the smaller circle. We are taking at a point, okay, which touches the smaller circle. Now this is how much? This is the radius of the larger circle. How much? 5 cm. And this one is radius of the smaller circle. How much? 3 cm. So this is O. Sorry, this is O. This is M. You can take any name or any letter you can use here. And this one A, B. So try to understand what need to find out. Find the length of the chord. So we need to find out the length of AB. Okay. Next, let AB is the common chord sorry, not common. Maybe I used the word common before, so it was my mistake. There is no common word. Okay, name of the direct AB is the code, because AB is only code of the larger circle. It's not code of the smaller circle. So we cannot use the word common. AB is the code of the larger circle which touches the smaller circle at M. Okay. Also, O is the center of the concentric circle. Given concentric circles or concentric circles. Clear? AB is the chord of the larger circle which touches the smaller circle at M. Also, O is the center of the concentric circle. To find AB, we need to find out what? AB. To find AB. Now see, here we know that using theorem that already I told you the line joining from the point of contact to the center is always perpendicular to the tangent, means radius is perpendicular to the tangent, means this is how much? 90 degree. So using theorem OM perpendicular to what? AB. Therefore we got in class 9, there is theorem that if the line which is coming from the center, if the line joining from the center to the chord, if we get it is perpendicular to the chord, then it will bisect the chord. Try to understand, means this line joining from center to this chord node, and also this is what? Perpendicular. If it is perpendicular, then it bisect. Have you remembered it? Because already you got in class 9, the line joining from the center to the chord, if it is perpendicular, then it bisect the chord. Means since we got by using theorem it is perpendicular, so we can write AM is equal to what? BM. By using that theorem, what we got in class 9. Therefore, what you can write? AM is equal to what? BM. Understood? Okay. Since it is 90 degree, now we can use Pythagoras theorem, because already we have OM and OA. So try to find out AM. Once you get AM, AM is what? Equal to what? BM. That means AB is what? Twice of AM. Or AB is what? AM plus BM. Once you get AM, AM is equal to what? BM. Using PT means Pythagoras theorem, OA square is equal to 3 square. 3 square means you know what is OM square plus AM square. You can write OM square here, but I wrote directly 3 square. OM means 5, 3 square means 9. This 25 minus 9, then AM square. 25 minus how much? 16. So AM square. So you understood? 16 square root is how much? It's therefore, okay. Therefore AM is equal to how much? 4 centimeter. So AB means what? AM plus BM. If AM is 4, since AM is equal to what? 4 centimeter, and also AM is equal to BM, and BM is also 4. That means AB is equal to 2 into 4. How much? The final result is how much? 8 centimeter. Understood? Okay. Next question. Question number 8. A quadrilateral ABCD. See, ABCD is what? Quadrilateral is drawn to circumscribe. Circumscribe means because the quadrilateral is drawn on the circumference of the what? Circle. Circumscribe. Like that you can say circumscribe. A quadrilateral ABCD means we can say that the total length of this boundary is circumference. Circumscribe means it is this quadrilateral we have drawn on here. That's why the word is circumscribe used here. circumscribe a circle, see given figure. Okay, prove that AB plus CD, AB plus CD and AD plus BC. Okay, solution. Okay, the figure already has given here. So using theorem, if you use theorem here, see, we know that the length drawn from the tangent, see, this is a tangent, but if you see clearly here, see, D is the external point, this is also a small tangent or not? This is also a small tangent. So we can use theorem here. The length of the tangent drawn from the external point, this is the external point, this is also one. This set means the length drawn from the tangent, drawn from the length of the tangent drawn from the external point. Maybe it is not clear. I am going to clear it. The length of the tangents drawn from an external point are always equal. Means this is the external point and this tangents are drawn. So we can say that these tangents are what? Equal. So we can write ds is equal to what? dr. Similarly, cr is equal to cq. These are also tangents. Or in this side you can take as is equal to ap. Next, what you can write? bp is equal to bq and also cq is equal to what? cr. So we got this one. Now see, to prove ab plus cd, ab plus these two sides, sum of these two sides is equal to ad plus bc. See, this is number 1, this is number 2, 3, 4. Now 8, all this like that. 1 plus 2 plus, nothing is there. Okay, what I use? Only the theorem that the length of the tangent drawn from an external point are always equal. That only. Okay, now left hand side, ds as bp cq dr, on the right hand side dr plus ap plus bq plus cr. Okay, so now see, you have to see the pairs. Those will give you ab cd. Okay, to get ab, what do you need? ap and bp. So try to find out ap and bp this side. See, this is as. Okay, as is equal to what? ap. So in the place of as, what you can write? ap. Then ap and what is here? pp. Then ap plus bp, what do you get? ab. Then you try to need to find out this side what? cd, because you need what? ab plus cd. So first this one you write. In the place of as, what you can write? ap. Then I am writing what? bp. Now what is there? ds and cq. Now what you need? cd. To need cd, what? cr and dr. Yes, ds and what is there? cq. So in the place of ds, see, ds, dr you can write. In the place of what? cq you can write what? cr. See, so ds you can write dr, cq you can write what? cr. Similarly for this side, what do you need? ad plus bc. ad plus bc. To get ad, as and ds, what do you have? ap. So in the place of ap, what you can write? as. And now need what? ds. So dr is here. See, dr. In the place of dr, what you can write? ds. Understood? This two things clear. Now bq plus cr, what do you need? bc. To get bc, bq plus cq you need, but bq already you have. bq, then one more cr, but you need what? cq. So in the place of cr I am writing cr. I think all of you understood this one. Nothing is there, only you have to see this relation and according to this you have to make it from this. Okay, now ap plus bp. ap plus bp what? ab. Similarly dr plus cr what? cd. And this side as plus ds what? ad. And bq plus cq. bq plus cq what? bc. Okay, understood? Okay, next question now. So next question number 9. In the given figure, xy and x dash y dash are two parallel tangents to a circle with center O and another tangent AB with point of contact C intersecting xy at A and xy dash this x dash y dash at B. Prove that angle AOB is equal to 90. See, there according to question, xy and x dash y dash are two parallel tangents. There is one more tangent, what? AB, point of contact is what? C, which intersect xy at, means according to question, another tangent AB, this is the AB, okay, and which intersect, means point of contact is what? C, and this A intersect at xy and B intersect at xy dash. You need to find out this one, this measurement AOB. Okay, solution. See, it is also easy, okay, very easy. Just try to understand. I hope all of you understood the question. First you write like that, we have xy parallel xy x dash what? Y dash. Next, in figure, join OC, this one usually. Okay, now you can see after joining there are two triangles. See, APO or OPA or OCA, yes or no? Okay. In triangle OPA and triangle what? OCA, try to show this triangle congruent. How need to show this congruent? You will understand after some time. So here you can write OP is equal to what? OC, because these are radius. Same radius. Next, what is here? OC is common, yes or no? Sorry, OA is common. This is A. OA is equal to OA. Next, A is the external point, so this tangent AP and AC are also small tangent or not. So you can use the theorem. The length of the tangent drawn from an external point are always equal. So AP is equal to what? AC. No need to write the full theorem, just write using theorem here. So by what criteria? These are congruent using what? SSS, side check. Triangle OPA congruent triangle what? OCA. So now they are congruent. If they are congruent, then you can say these angles are equal. Yes or no? This is angle 1, this is angle 2. Okay? Angle 1, angle 2 you can write. Because this triangle, two triangle are congruent according to CPCT, angle 1 and angle 2. Therefore, angle 1 is equal to angle 2. CPCT. If you use, means if you so these two triangles are congruent, like OQB and OCB, then these two triangle angles are also equal. So no need to show congruent, just you write similarly 3 and this angle is what? 4. You write like this. Similarly, angle 3 is equal to angle 4. Understood? Okay. Now see, since xy is x dash y dash, xy parallel to x dash y dash, already I wrote here. So if they are parallel, then angle A, pull this angle A plus angle B is what? Same side of the transversal. So their sum is 180. Now angle A plus angle B is equal to how much? 180. Why? SST. SST means, you know, already I have told you in the class 9 that this shortcut of same side of the transversal. So what is angle A? So angles consist two angles, 1 and 2. So angle 1 plus angle 2 means angle A, and angle B is angle 3 plus angle 4. Understood? Okay. Now you can write, see, since angle 2 is equal to what? Angle 1 and 2 are equal or not? So in the place of angle 1 you can write angle 2 or not? You can write. So this is, if you write angle 2 here in the place of angle 1, then angle 2 plus angle 2 what? Twice angle 2. Similarly, angle 3 and angle 4 are equal. If you write in the place of 4 angle 3. So angle 3 plus angle 3, twice angle 3. What is left? 180 degree. What do you got? That if you take common 2, then angle 2 plus angle 3, and this is how much? 180 degree. Then angle 2 plus angle 3, if you transfer 2 on the right hand side, it will be divided the 2 how many times? 90 times. So angle 2 plus angle 3 is equal to how much? 90. Clearly, what do you got? Sum of these two angles, this one and this one. Now if you see the triangle separately AOB, then you see this 2 and 3 already got. Then what is left? Only this angle left in this triangle. In the triangle AOB, you got already the sum of these two angles, 2 and 3. How much? 90. Then what is left? This one. We know that the sum of the three angles of a triangle is how much? 180 degree. Already you have the sum of these 2 and 3 is how much? 90. Then obviously angle AOB is what? 90. Because this 2 is 90 and this is 90. Yes or no? So using what? Angle sum property, you can find out this is what? 90. So in triangle AOB, therefore in triangle AOB, angle AOB is equal to, you can write 180 minus angle 2 plus angle 3. Try to understand, because that already you got the sum of two angles, only one angle is left. There is this sum will minus from 180. So what? 90. Don't forget, here we are using what? ASP, angle sum property. Okay, so angle AOB is 90. Understood? You got? At last, this angle is how much measurement? 90 degree. At last. Okay. Next question. Okay. This is question number 13. Prove that opposite sides of a quadrilateral circumscribing. Already I explained this word. Prove that opposite sides of a quadrilateral circumscribing a circle subtend supplementary at the center of the circle. I know you did not understand this question. Okay. I'll make it easy. See the figure. This is a circle. Okay. Prove that opposite sides of a quadrilateral circumscribing. You have to draw a quadrilateral who is circumscribing this circle. Circumscribing means already you know, I explained. I already told you that please use compass and scale, okay, to get proper diagram, means for tangents, to draw tangents and circle. I am not using that. You have to use, okay. Now see, I cannot use scale or pencil, because you know already that I am using both the hand. I am holding the phone by my left hand and I am writing by using my right hand. That is why I could not use scale and pencil. Okay. My thing is that you should understand the conception. If once you understand this sums, you can do yourself. Prove that. Now see, suppose this is a ABCD quadrilateral has drawn circumscribing a circle of center O. Now see, we need to prove that a circle subtends supplementary angles at the center. Opposite sides of a quadrilateral means this side. See, if subtend means what? From this CD subtend and here this angle, and from this opposite side is what? See, opposite side is what? AB. Subtend this angle or not? You need to prove that this angle and this angle, when you add these two angles, they are how much? Supplementary means how much? 180 degree. Similarly, AD means AOD and BOC, these two angles, when you add, they are also supplementary means what? 180 degree. So how do you prove it? So for this, so these are what? P, Q, R and S. Join. Okay. Let ABCD is a quadrilateral. Those questions they have not given the figure, and also sometimes they have not given anything, means symbol like A, B, C, D. So that time you have to explain the figure first. Okay. You have to give little explanation of the figure, then only you can start the sum. ABCD is a quadrilateral describing a circle of center O. Okay. Also P, Q, R and S are the points of contact. Clear? Next, you can see here join OR, OS, OP and OQ. So right here, join OS, OR, OQ and what? OP. Okay. Now see here, these are angles. Okay. So this is angle 1. Numbering the angles. Okay. So this is 3. This is 4. This is 5. This is what? 6. This is 7. And this is 8. So already you know that I have done like that. If this is a center, please draw the figure clearly. Okay. I am not using pencil, that is why it become like that. I hope all of you understood. In case any doubt, please contact me in my WhatsApp or through my WhatsApp. So see, you can triangle ORD and triangle OSD. OS is equal to what? OR. DR is equal to what? DS. And OD is common. By using SSS, you can show these two triangular congruent. Like that already I have done here. Yes or no? This one, OPA and OCA, same thing or not? So now why I have shown this one, because now I am not going to show how these are congruent. I am going to write directly. In exam also you write directly. Okay, no need to show how these are congruent. Just you write like that. We have triangle OSD congruent triangle ORD. See, OSD and ORD. If these two triangular OSD and ORD is congruent, then what? Angle is equal to what? Angle 2. Therefore, angle 1 is equal to angle 2. Why? CPT. Similarly, what you can write? 3 is equal to 4, 5 is equal to 6, 4 is not equal to 5. See, this is the difference. These are triangles, 3 and this one and this one triangle. So 3, 4, 5, 6, 7, 8. So you can write angle 3 is equal to angle 4, angle 5 is equal to angle 6, and angle 7 is equal to angle what? 8. Now what we can write? We know that. What do we know? If we add all these angles, then how do you get? 360, this complete angle. So angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6 plus angle 7 plus angle what? 8 equal to how much? 360. Okay, now what need to prove? I forgot to write before, so see, we need to prove what? AOB plus COD. Already I told you that AOB and opposite is what? COD. The sum of these two angles is how much? 180. And similarly AOD and plus BOC. AOB plus COD is 180 and AOD plus BOC is 180. These two things we have to prove. See, now first of all, suppose we need to, any one you can choose. Suppose AOB plus COD. To need angle AOB, we need angle 4 and 5. And to need angle for angle COD, you need what? 1 and 8. Which we need these angles 1, 8, 4, 5. So can you make 1, 8, 4, 5 from this all? Yes, because already you know 1 and 2 is also equal to what? 1. Yes. Ink finished. So I am using this pen now. See. So this is also 1. Now we don't need 3 no. So 3 and 4 are equal. So in the place of 3 you can write what? 4. Then again 4. So 5 we need 5 and 6 also equal to what? 5. 7 we don't need. So then 8 we need 8. So 7 and 8 are equal. 8 in the place of 7, 8. Then what is left again? 8. see, I change the angle because they are equal. Okay, without, so I have to say that if they are not equal, we cannot change it. They are equal, that is why we can change it. So angle 1 plus angle 1, twice angle 1, twice angle 4, twice angle 5, and at last twice angle 8, equal to how much? 360. This is 5. Okay, so you can take common what? 2. What is left? 1, 2, 4, 5, 8, equal to how much? 360. What is 360? This complete angle is. So now 1, 4, 5, 8, and 360. If you transfer this to this side, how much you will get? 180. So now see the figure once again. What do you need? 4, 5 and 1, 8. See, 4, 5, 1, 8. So write like that in pair. 1 plus 8 and what? 4 plus 5. That's the variance. Okay, now 1 plus 8 will give you what? COD, and 4 plus 5 AOD. So you can write here angle COD plus angle what? AOD. So on already you got proof like that. So similarly you can prove another, means once you are getting AOB plus COD 180. Similarly you can write what? AOD plus BOC. Similarly you can prove AOD plus what? BOC. Similarly angle AOD plus angle BOC is equal to 180. So understood what we have done? Just numbering all the angles, then we add how much you got? 360. Then we have changed according to the angles. Then we got the answer. Understood? Okay. See your homeworks. Homework, only there are 3 homeworks: 10, 11 and 12. These 3 homework. Okay. I have completed 4 sums made today. In case any doubt or confusion, please ask me through WhatsApp. Okay. I have completed this chapter today, and this is very small chapter. So after this chapter, I will see which chapter is suitable for you. I will start that chapter in the next class. In case any doubt from this chapter, conception, anything, please ask me through WhatsApp. Thank you so much. Have a nice day ahead.